New angel challenge that was only find the string with LCP. LCP matrix is defined here, so it's basically some random word generated here with some random symbols, and we got the from I until n-1 and until j and n-1. It should be the longest common prefix between these substrings, which are defined here. So for example, taking this number, they got 4, then we got 3, then we got 2, then we got here since it's the diagonal. Let's do it with implementation of checking diagonal first. So we got the length of our MCP since it's matrix n multiplied by n, so amount of rows and columns is the same. So we're checking in range of n and checking if the LCP ij is basically equal to the n-1. And if it's not equal, just return empty string. So we're gonna define some helper methods. So we define the list of range n, and we define two methods. First of all is find, second one is union method x, y. So first one searches if parent x is not equal to x. It means parent x is assigned parent x in a recursion, basically, and we're returning our parent x. Second method will do the parent x find x and assign it to find. Then we union the positions and form these values. So we're iterating in range n for j in range n, and if the LCP ij is greater than 0, since we perform our search where union ij fun. Next step, we're gonna try to assign the chars to our given pairs. So result is empty string multiplied n times, and current char is, since we need to find the minimum one, so we're iterating until, so we're forming our sets here, and if current char is greater than last one of the alphabet, we just return empty string here. And in other cases, we just assign group to char root, assign it to char of current char. Char is incremented, and result I is assigned to group to char root. Our resulting word is basically the result. Let's join it, join result. Since we already created our word, so basically this is the answer, but we should check on the last step if it's basically an LCP. So we're forming the algorithm and checking, building our LCP matrix here for in range of n+1. And let's start our iteration over in range starting from n-1, -1, second one for j in range, the same one, -1, -1 increment here, and we're checking if the word I is equal to word j. This means update the state of our dynamic programming approach here, j +1 +1. So, and the second one, we're iterating for in range of n, for j in range n, checking if our current ij result is not equal to the original matrix, which is LCP ij, in this case returning blank string. So let's try submitting our solution to see what a small typo here. Here is double I. In this case, we're checking the diagonal. Here we're checking a small typo here, also fixing it to n-I. Let's try resubmitting it, and we're actually done. So thank you guys for watching. See you next day.